Now, once again, in these final 4 examples, I am going to encourage you to stop right now, stop the video and try and work these out on your own, right? Even if you get stopped, just try to solve for something. Try to figure out what the question is asking for, what the missing pieces are, and then use your calculator to solve for the solution. Don't use the video as a crutch. The only way you're going to know if you can actually do these on the exam when it matters is to practice it here and in the homework, right? So try to force yourself to do it. These shouldn't take you very long. There's 4 questions here. These are questions from old exams, so they're laid out exactly like I would ask an exam question, where the compounding period is very explicit, where there is nothing to assume about anything in the problem, right? And they highlight some relationships between the time value of money functions that are really important going forward. Okay, so stop, try them on your own, then come back and watch the solutions. Okay? Now the first question here says, at 6% interest compounded annually, how many years would it take for a $100 investment to grow to $133.82? Right? Now, again, first question, what are we trying to solve for? And this is pretty clear because we see how many years would it take. That means we're solving for in the number of periods. And that means we need to know the present value, the future value, and the rate that we're going to earn in order to solve this problem. So we're going to make an investment, and we're going to start with 100, and we're hoping to grow it to 133.82. That means our present value is 100, but that's a cash outflow, so it is negative 100. Our future value is 133.82. That's what we want to grow to. And our IY is 6%. And here, again, very explicitly, compounded annually, so 6% per year. And that means our in, how many years, is going to come out exactly the way we need it. How many years is it going to take? Well, our output will agree with our input period, so our answer will be in years, and we won't have to do any additional conversion. Start by clearing the time value of money, second, and future value. Then we plug our answers in. We have an investment of $100. That's a cash outflow, so it's a negative. So negative 100 is our present value. Future value is 133.82. That's what we want to get to. And we are going to earn 6% per year on the way. That's a 6 and IY. Then we compute our in, and we get 4.999997%. Per year. Oh, sorry. No, not percent. 4.999997 years. This is the in. And I will always round to 2 digits here, and so this will round up to 5 years. So if I want to turn 100 into 133.82, I gotta wait 5 years to do so. Now, if you invested $100 now, so same investment amount, but in 5 years it grew to 146.93, what rate of interest would you be earning? Again, something I want you to think about here, even though I've already asked you to solve the problem, something I want you to think about is that if we invest the same amount and it grows to a larger amount in the same amount of time, how should that affect our rate of interest? Should it be larger or smaller? And hopefully the answer is clear. If I start with 100 and in the same amount of time I get to a larger amount, it must mean that I was earning a larger interest rate. And we can see that play out here. We can just check our work. Again, I'm solving for IY. It says what rate? That means I need to know the present value of the investment, the future value of the investment, and the number of periods that the investment lasts. The present value here is 100. Again, I'm investing, and that's a cash outflow, so negative 100. It's the same as the previous problem. Differently here is the future value. The amount that it grows to is 146.93, but it does so in exactly the same time frame, 5 years. What I want to know is how the rate must have changed. And we know it should be bigger, but how much bigger? Well, let's see. We'll start by clearing our time value of money function. We'll start with a $100 investment. That's a cash outflow. It's got to be a negative. Negative 100 is our present value. Future value is 146.93. That's how much it's going to grow to. And it's going to do so in the same time frame, 5 years. So 5 is our in. Then we compute IY and we get 7.996%. And again, we round that to 8%. And that is an annual rate because we have an annual input. Output period and input period should be the same. So we see that we earn almost 2% more per year to have a higher future value in the same amount of time. Right. Okay, third problem. How much would I need to invest today at 9% compounded annually for my investment to grow to $5,000 in 3 years? So again, first question we ask ourselves is, what is the problem trying to solve for? And here the problem is trying to solve for the amount that I need to invest now. Again, the keywords we're looking for to determine whether we have a present value or future value problem is something like this. How much do I need to invest today? That's telling me I want to determine what my present value is in order for me to get to the future value in 3 years. So I have a present value problem. That means I want to know the future value, or I need to know the future value of the account. The length of time, the number of periods the account is in existence, and the IY, the interest rate that the account is going to earn. So I have my investment. I want my investment to grow to $5,000. I want it to do so in 3 years. And my interest rate is going to be 9% per year. Again, the interest rate is what's telling me the compounding period. And here it says the interest is compounded annually, so I know this is yearly. That means my in is going to be yearly. I don't need to do any additional conversions. So what I want to solve for is the present value of the account. What do I need to start with in this investment in order to get where I'm going? So I clear my time value of money buttons. Then I start with future value. $5,000 is my future value. That's where I want to get to. I have 3 years in this investment account, so 3 and then in. And I'm going to earn 9% per year while I'm doing so, so 9 is my IY. I compute my present value and I get negative 3,860.9174, which again, ultimately will round to 0.92. And that's the amount that I need to start with. Now, something that I haven't mentioned yet, and I should have mentioned earlier, is that your answers on your homework and exams always be a positive amount. Even though the calculator is treating this as a negative, it's important to remember that that's not actually a negative investment is not actually how it works. That's just the accounting convention for spending and receiving. If we're actually investing, we're not investing negative $3,000, we're investing $3,000. And so the instructions will be clear, but it is something that you need to keep in mind. Likewise, if you're doing this with a graphing calculator, you can use, the financial functions are in the graphing calculator. Again, please go to the instructions so that you can figure out how to get there. Okay, final problem here for chapter 5 is that we expect to inherit $1 million from a trust and when we turn 30 years old. Now, prevailing interest rates are 4% compounded annually. And prevailing here just means the current rate. This is the rate that prevails in the market. So interest rates are 4% compounded annually. How much is this trust worth to me today? Assume you just turned 22 years old. Okay. So the question is, again, given away by this. How much is it worth to me today? So I'm asking about what the present value of this $1 million that I'm going to receive in the future is going to be. So that's present value problem. where the future value is the $1 million that I'm going to receive. Right? And my N is the difference, is the length of time that this investment occurs. And that's simply the difference between how old I am and how old I'm going to be when I get this account, when I get this trust, which is 8 years. And then my IY is the amount that this trust is earning every year, which is 4%. And what I'm computing is the present value, how much this trust is worth, if somehow I was able to get after it now instead of 8 years from now. So I'll start by clearing my time value of money. Future value here, $1 million. N is 8. That's the difference between how old I am and how old I need to be to get the trust. 4% per year is the amount that the trust earns. And I compute my present value. And I get that the value of this trust right now is $730,690 and about 21 cents. Now, this is actually a somewhat common calculation. It might seem kind of weird because you can't get the money, but there are businesses that completely operate like banks that buy trusts and settlements in advance. So you sue somebody and you get a settlement, you get hurt and you get a settlement. Maybe you have a trust that your grandparents left you and you get a settlement. If for some reason you actually need the money, this is entirely the calculation that would go on behind the scenes, and these companies will buy these trusts or settlements from you in advance and give you the present value of those things. So this is something that actually can go on here in the real world, and this is how we would calculate it.